Consider this problem. The marks obtained by Sukriti in the first two unit tests are 75 and 70. Find the number of minimum marks she should get in the third unit test to have an average of at least 60 marks. Now we have to consider this word at least. Average of at least. Okay. So when we find the average of these three subjects, she must get a minimum of 60. So at least corresponds to greater than or equal to 60. So that we have to remember. So they have given the marks secured in the first two unit tests. First two unit tests are 75 and 70. Let us assume that the third test mark be equal to x. Third test mark be x. Now we are supposed to find the minimum mark she should get, so that the average of these three subjects is at least 60 marks. So we find the average. How to find the average? How to find the average of three subjects? We must add the marks of the three subjects and we have to divide by 3. So 75 plus 70 plus x by 3, and this should be greater than or equal to x. It should be greater than or equal to 60 marks. So we simplify the numerator, left hand side of the numerator. 75 plus 70, which is 145 plus x divided by 3, greater than or equal to 60. So this is the inequality. We have to simplify this inequality. So first we try to remove the 3 in the denominator. So for that we have to multiply by the multiplicative inverse of 1 by 3. So multiplicative inverse of 1 by 3 is 3. So we multiply by 3 on both sides. So multiply by 3. So 3 into 145 plus x by 3 greater than or equal to 3 into 60. So left hand side, this 3 is getting cancelled. So it is 145 plus x greater than or equal to 3 into 60. 3 into 60 is 180. So x is greater than or equal to 145 plus x is greater than or equal to 180. Now this 145 is in addition with this x. So how to remove that 145 on the left hand side? We have to add by the additive inverse of 145 on both sides. So we simplify this expression further. (145 plus x minus 145 greater than or equal to 180 minus 145. So 145 getting cancelled on the left hand side. So x is greater than or equal to 180 minus 145. We have to subtract. So when you subtract, the answer will be 35. So she has to score minimum of 35 marks to get the average 60 and above. Okay. So she has to get 35 marks minimum in the third unit test to have an average of at least 60 marks. Is it clear, students? We move on to the next question. Now let us consider this question. Satyarth and Swarit are brothers. Satyarth owns a house which is worth of 3 crores and Swarit owns a farmhouse which is worth of 2.75 crores. So both are having a property worth of 3 crores and 2.75 crores respectively. Okay, but Satyarth is going to have a debt of 55 lakhs. If they both sell their properties, then which of the following statements holds true to represent the above data mathematically? Satyarth's net worth is more than Swarit's net worth. Okay. So Swarit's net worth is more than the Satyarth net worth. And next, last one is 2.45 is less than 2.75. Okay. Now, by reading the question, we can understand that Satyarth is having a own house which cost rupees 3 crores, but he is having a debt of 55 lakhs. He is having a debt of 55 lakhs. But Swarit is having a farmhouse. Swarit is having a farmhouse which cost 2.75 crores. He has no debts to repay. Is it clear? So to find the solution, we try to calculate the net worth of both the persons. First one, Satyarth. He is going to have own building, cost 3 crores. Okay. But he is going to have a debt of 55 lakhs. So when he sells his building, he will be getting 3 crores, but he has to repay his debt of 55 lakhs. So what is net worth of Satyarth? Net worth of Satyarth is 3 crores minus 55 lakhs. Okay. So you will be having 3 minus 0.55. So you will be having 2.45 crores. So Satyarth net worth will be 2.45 crores. I take this as X. Whereas for Swarit, he don't have any debt, but he is having a own farmhouse. He is going to sell it for 2.75 crores. So net worth of Swarit will be 2.75 crores. Okay, I take this as Y. Now we are going to write this as mathematically. Satyarth net worth is more than Swarit's net worth. Satya's net worth is X and Swarit net worth is Y. So they are saying X is greater than Y. Okay, which is false. This is false. Why this is false? Because we are having Satyarth net worth is 2.45 crores, whereas Swarit net worth is 2.75 crores. So Swarit net worth is more than Satyarth. So here Swarit net worth Y more than X. This is true. And obviously 2.45 less than 2.75. This is also true. Okay. So mathematically, if you want to write, Satyarth net worth is more than Swarit net worth. X is greater than Y, which is false. B. Swarit net worth is more than Satyarth net worth. This is true. And the third one, 2.45 less than 2.75. That is 2.45 is X less than Y. This is also true. Okay. So these are the word problems related to linear inequalities. Simple linear inequalities. Okay. Now, if A and B are any two integers, okay, A and B are any two integers, any two positive integers or positive numbers. Now we are going to see relation between arithmetic mean and geometrical mean. We are going to study about the relation between arithmetic mean and geometrical mean. Let A and B be any two positive numbers okay. Arithmetic mean of these two numbers is A plus B by 2. Geometrical mean of these two numbers will be geometrical mean. Here we have to find the product of A and B. Because we multiply two numbers, we have to take square root of A by E. Now what is the relation between arithmetic mean and geometrical mean? The relation between arithmetic mean and geometrical mean is AM greater than or equal to GM. Arithmetic mean will be greater than or equal to geometrical mean. Suppose we take three numbers. Let A, B, C be, let A, B, C be any three positive numbers we must impose the condition they must be positive. Okay, because when we take square root we will be having problem when the numbers are going to be negative. Okay, so arithmetic mean will be equal to, because we are going to find the arithmetic mean of three numbers, it will be A plus B plus C by 3. Geometrical mean, we are going to find the product of three numbers. So product of three numbers, but we are not supposed to take square root, we have to take cube root, because we find the product of three numbers. For geometrical mean we have to take cube root of the product of the three numbers. So cube root of ABC. Here also we have the condition AM will be greater than or equal to GM. Okay, they will be equal when all the numbers are same. If all the numbers are going to be same, A equal to B equal to C, then we will be having the equality value. Okay, what happens when it is four numbers? Let A comma B comma C comma D be any four positive numbers. Then arithmetic mean of four positive numbers AM. We are going to find the arithmetic mean of four numbers. So it will be A plus B plus C plus D by 4. Geometrical mean. So for geometrical mean we have to find the product of four numbers. So we multiply four numbers A, B, C, D. Since we multiply four numbers, we have to take fourth root of the four numbers, product of four numbers. So here also we have the condition AM is greater than or equal to gm. Okay. So arithmetic mean of two numbers, arithmetic mean of three numbers, arithmetic mean of four numbers, geometrical mean of 2, 3, 4 numbers we have seen here. In all the cases, arithmetic mean will be greater than or equal to geometrical mean. Using this concept, we are going to prove certain inequalities. Okay. Now consider this question. If A, B and C are positive real numbers, then prove that the following using AM, GM inequality. Okay. We are going to prove this expression 1 plus A square into 1 plus B square greater than or equal to 4AB. Okay. Now we are going to apply arithmetic mean for 1 and A square. Consider two numbers 1 and A square. I am going to find arithmetic mean, I am going to find geometrical mean, and I am going to relate them using arithmetic mean, geometrical mean inequality. Okay. So what happens for this 1 and A square when I apply arithmetic mean? Arithmetic mean will be 1 plus A square. Geometrical mean root of 1 into A square, that is equal to we are going to solve this inequality 1 plus A square into 1 plus B square greater than or equal to 4AB. Here we are having two terms, one is 1 plus A square and the other one is 1 plus B square. So with 1 plus A square we are going to form one equality, and with 1 plus B square we are going to form another inequality. We are going to merge together. Okay. First we are going to consider 1 plus A square. For that two numbers we are going to consider 1 and A square. For these two numbers 1 and A square, I apply arithmetic mean. Arithmetic mean will be equal to 1 plus A square by 2. Geometrical mean will be equal to root of 1 into A square. Because we are going to take only two numbers, it is the product of two numbers, so we have to take square root only, which is nothing but root of A square, that is equal to A. So by AM-GM inequality, we have AM is greater than or equal to GM. So we apply this inequality. So we get 1 plus A square by 2 greater than or equal to A. And for the second one, I am going to apply the value. For 1 comma B square, arithmetic mean will be 1 plus B square by 2, and geometrical mean will be equal to square root of 1 into B square, that is equal to root of B square, that is equal to B. So I connect this AM-GM with AM-GM inequality. So in that case, we get 1 plus B square by 2 greater than or equal to B. And we have X greater than or equal to Y and A greater than or equal to B. Because all are going to be positive numbers, I multiply. Okay, in that case, AX will be greater than or equal to BY. So this is the first inequality, this is the second inequality. So I am going to multiply. When I multiply, what I will get? One plus A square by 2 into 1 plus B square by 2 greater than or equal to A into B. Now if we simplify the left hand side, it will be 1 plus a square into 1 plus b square by 4 greater than or equal to ab. Now I want to remove the 4 in the denominator of the left hand side, so I multiply by the multiplicative inverse of 1 by 4, that is nothing but 4. So I multiply with the 4 on both sides. So in such case, what I will get? 4 into 1 plus a square into 1 plus b square by 4 greater than or equal to 4 into ab. So 4 getting cancelled on the left hand side. So we get the ultimate answer. The final answer is 1 plus a square 1 plus b square greater than or equal to 4ab. So we proved the required inequality. Okay. So we have to study the left hand side to derive the answer. Okay. How many factors we have? 2 factors. What are the numbers which are related? 1 and a square. So we have to apply arithmetic mean for these 2 numbers. So when we see the question itself, we will get an idea for which terms we are going to take arithmetic mean, so that we get the inequality. We get the desired inequality. Okay. We consider another problem in this same type. So here we are having another question. If a, b and c are positive real numbers, then prove that the following using AMGM inequality. What is AMGM inequality? What is AMGM inequality? For any 2 or for any set of real numbers, okay, if you take arithmetic mean and geometrical mean for the set of real numbers, positive numbers, then AM is always greater than or equal to GM. Okay. Now we are going to prove this inequality. A square B plus B square C plus C square A multiplied with AB square plus BC square plus CA square greater than or equal to 9A square B square C square. Okay. So left hand side we are having 2 terms in product, and each term is going to have 3 terms. So we are going to consider 3 numbers. A, B, C are given, but we are going to consider the terms A square B, B square C, C square A. So for these 3 terms, I am going to apply arithmetic mean. What is arithmetic mean of these 3 numbers? AM will be equal to A square B plus B square C plus C square A divided by 3. This is your arithmetic mean. What is geometrical mean for these 3 numbers? Geometrical mean of these 3 numbers will be equal to cube root of. Why we have to take cube root? Because we are going to multiply 3 terms. Which are all the terms? A square B, B square C, C square A. When you multiply, it is cube root of A square into A. It is going to be A cube, B cube, C cube. So which is A cube, B cube, C cube whole power 1 by 3. So if you use the law of indices, the final answer will be A, B, C. Am I clear? And what is the inequality? AM is greater than or equal to GM. So when you apply the inequality, we get A square B plus B square C plus C square A by 3 will be greater than or equal to A, B, C. We take this as first inequality. We take this as first inequality. And I am going to apply the same property for the next term. The next term is going to be AB square BC square CA square. I am going to apply arithmetic mean for these three terms. When you apply arithmetic mean for these three terms, arithmetic mean will be equal to AB square plus BC square plus CA square by 3. Okay. What happens to your GM? Geometrical mean for these three terms will be again cube root. Tell me why we have to take cube root? Yes, we are going to multiply three terms to find the geometrical mean, so we have to take cube root. When we multiply two terms, we have to take square root. Because here we are multiplying three terms, we have to take cube root. So it is going to be AB square into BC square into CA square. When you multiply cube root of A multiplied with A square, A cube, B square is multiplied with B, so B cube, C square is multiplied with C, C cube. So it is equal to A cube, B cube, C cube whole power 1 by 3. So when you simplify, this is going to be again ABC. Okay, and if you apply the AM GM inequality, AM is always greater or equal to GM. Your AM is this expression, AB square plus BC square plus CA square divided by 3. And this expression is going to be greater or equal to ABC. So we write. So AB square plus BC square plus CA square divided by 3 is greater or equal to ABC. This is second expression. And we know very well, if A is greater than or equal to B and C is greater than or equal to D and all are going to be positive numbers, left hand side we can multiply, AC should be greater than or equal to BD. So we apply same property here. Using this property, what will happen? I multiply this first and second. Left hand side multiplied with left hand side, right hand side multiplied with right hand side. So we get the expression A square B plus B square C plus C square A divided by 3 multiplied with AB square plus BC square plus CA square by 3 greater than or equal to ABC multiplied with ABC. Okay, right hand side we are having ABC and ABC. Is it clear? Now left hand side we simplify, we get A square B plus B square C plus C square A multiplied with AB square plus BC square plus CA square divided by 9 greater than or equal to, right hand side is ABC whole square. So left hand side we have divided by 9. Left hand side we have divided by 9. So we have to remove that 9. So what we are supposed to do when you want to divide, when you want to remove that 1 by 9? Yes, exactly. We have to multiply it with the multiplicative inverse of 1 by 9. Multiplicative inverse of 1 by 9 is 9. So we multiply by 9 on both sides. So multiply by 9. So you get, so we multiply by 9 into 9. So what we get? 9 into A square B plus B square C plus C square A into AB square plus BC square plus CA square by 9 greater than or equal to 9 into A square, B square and C square. Here we get 9 cancel. Okay. So when you cancel the 9 on the left hand side, we get the required answer. What is the answer? A square B plus B square C plus C square A multiplied with AB square plus BC square plus CA square is greater than or equal to 9 A square, B square, C square. Is it clear, students? We move on to next question. Again, see here. If A, B, C are positive real numbers, then prove the following using again AMGM inequality. Okay, AMGM inequality. Left hand side we are having A plus B whole square greater than or equal to 4AB. Is it clear? A plus B whole square greater than or equal to 4AB. We are supposed to prove this one by AMGM inequality. So we know what is AMGM inequality. Okay, arithmetic mean is always greater than or equal to geometrical mean for any set of positive real numbers. Okay, now we are having A plus B whole square. I try to write this as A plus B whole square greater than or equal to 4AB as A plus B into A plus B greater than or equal to 4AB. So I try to prove this expression. Is it clear? So for that we are going to consider two numbers, A and B. For A comma B, arithmetic mean is going to be A plus B by 2. Geometrical mean will be root of AB. Is it clear? Because it is the product of two numbers, we have to take only square root. And we have the inequality AM greater than or equal to GM, which implies A plus B by 2 is greater than or equal to root of AB. Now, for the same A and B, same thing only we are going to do it, okay? A plus B by 2. So, we multiply both sides. Or you can take the inequality. What is that? If x is greater than or equal to y, x square is also greater than or equal to y square. So, we consider that inequality property. So, we take A plus B by 2 whole square greater than or equal to root of AB the whole square. So left hand side it becomes A plus B the whole square by 4. Right hand side we get AB whole power 1 by 2 whole square. So the square and square root get cancelled each other. So we get this expression A plus B by 2 whole A plus B the whole square by 4 greater than or equal to AB we get. Left hand side we are having 4 in the denominator. We want to remove it. So what we are going to do? Multiply by multiplicative inverse of 1 by 4. So we multiply by 4 on both sides. So 4 into A plus B the whole square by 4 greater than or equal to 4 into AB. So we cancel 4 on either side. So we get A plus B whole square is greater than or equal to 4AB. So these problems are based on the AM, GM inequality, arithmetic mean and geometrical mean of the numbers. Okay. Now this also going to be the application of AM, GM inequality. If x is a positive real number, then find the smallest value of x square plus 361 divided by x. Okay. So how to apply AM/GM inequality for this expression? Expression is x square plus 361 divided by x. So for applying arithmetic mean, geometrical mean inequality, we must have two numbers. So we try to write this as sum of two numbers. So this I will take it as x square by x plus 361 divided by x. So this is nothing but x plus 361 divided by x. Is it clear? Now I am going to apply arithmetic mean and geometrical mean for these two numbers. So we consider the two positive numbers x comma 361 by x. So what is arithmetic mean of these two numbers? Arithmetic mean of these two numbers will be sum of these two numbers divided by 2. So it is x plus 361 by x divided by 2. So which is nothing but x square plus 361 divided by x by 2. We take LCM for these two numbers. When we take LCM, it will be x square plus 361 by x divided by 2. We need not simplify this one by bringing that x to the denominator. We try to keep this as such. Okay. What is geometrical mean for these two numbers? Geometrical mean of these two numbers will be square root of x into 361 divided by x. Now x and x will get cancelled. It is going to be simply root of 361, which is nothing but when you take square root for 361, it is going to be 19. Okay. Now we are having the inequality. AM greater than or equal to GM. AM greater than or equal to GM. So apply this one. So you will get x square plus 361 by x divided by 2 greater than or equal to 19. I want to remove this 2 in the denominator. So I multiply by 2 on both sides. Okay, 2 is nothing but the multiplicative inverse of 1 by 2. So we multiply. So 2 into x square plus 361 by x divided by 2, which is greater than or equal to 2 into 19. Okay, I cancel this 2 and 2. So we get this expression x square plus 361 by x is greater than or equal to 38. So whatever may be the real number x, x square plus 361 divided by x will be always greater than or equal to 38. This is the conclusion we get from this expression. Whatever may be your real number x, okay, x square plus 361 divided by x will be always greater than or equal to 38. So the smallest value will be smallest value will be 38. Is it clear, students? Now we are going to see solution of system of linear equation. What do you mean by system of linear equation? Linear inequality we know. Okay. System means set of inequalities having same variable x. Okay. And we are going to consider in one variable. That one variable will be x. So we will be having more than one inequality. Is it clear? And we are supposed to find the value of x which will satisfy that set of inequalities. Then how to solve this? How to find the solution? We have to solve the inequality individually. Okay. And we have to find the set which will satisfy the given set of inequalities. Okay. Suppose if you have an inequality ax plus b greater than or equal to c. This is an inequality. We will get a solution set here satisfying this inequality. And we are having another inequality px plus q less than or equal to r. We solve this linear inequality by previous methods and we try to get the solution set. This solution set will be satisfying this inequality and this solution set will be satisfying this inequality. If it is given individually, the problem will be solved in that particular stage. But this is going to be system of linear inequalities. So we are supposed to find the solution set for the first set of first equation and the second equation, and we have to find the suitable solution set for x which will satisfy both the inequalities. We have to find the value of x which will satisfy both the inequalities from the solution set obtained. So that is very important. Suppose we are going to have another set of another inequality. Is it clear? Lx plus my is greater than or equal to n. Another set of another inequality. Okay. So this is called a system of linear inequality. So inequality, more than one inequality So we conclude by this expression. What is the system of linear inequalities? System of linear inequality will be set of linear inequalities. That is called system. Is it clear? It will not be one inequality. It will be more than one inequality. Okay. So if we are having three linear inequalities, if we are supposed to solve it, so we have to solve the inequalities individually. Okay. First we have to get the solution for this inequality and second inequality as well as this one. Okay. Third inequality. We will get another solution set. So we have to find the common solution set for x which will satisfy all the three inequalities. So this is called as system of linear inequalities in one variable. Okay. We will make ourselves familiar in this solving this type of linear inequalities, system of linear inequalities. Now we have the inequalities, system of inequalities. Here we are having two inequalities. One is 4 minus 5x greater than minus 11. Another one 4x plus 11 less than or equal to minus 13. So we try to solve the first inequality. First inequality is going to be 4 minus 5x greater than minus 11. Yesterday itself we studied how to find the solution for this one. Okay, left hand side we are having an x term and a constant term. Now we are in the process of removing the constant term 4. So I want to remove this 4. So what I should do? I subtract 4 on both sides. So it is 4 minus 5x minus 4 greater than minus 11 minus 4. So 4 cancel. So we get minus 5x greater than minus 15. Now I am having a number 5 and negative sign on the left hand side. Okay. Now I divide by 5. Why we have to divide by 5? Because multiplicative inverse of 5 is 1 by 5. So, or you can say that multiply with 1 by 5. So multiply with 1 by 5. So 1 by 5 into minus 5x greater than 1 by 5 into minus 15. So 5 cancel. So here if you cancel, this is 3. So minus x is greater than minus 3. And I am having negative sign with x. So we multiply by minus 1. So we have to be very careful when we multiply with minus 1. Why? When you are multiplying with a negative number, the inequality getting reversed. So when you multiply with a minus 1, it will be minus of minus x, inequality is reversed, minus of minus 3. So which implies x is strictly less than 3. So here we are having a solution set for what is that? X. Solution set for this one will be less than 3. Less than 3 means minus infinity, because we don't have equal symbol in the inequality. It is an open interval 3. So we are having 3 open So left hand side fully. So this is the solution set for the first inequality. Now we consider the another inequality, second inequality. (4x plus 11) less than or equal to minus 13. So I want to remove this 11. So what I should do, it is plus 11. So additive inverse of plus 11 is minus 11. So what we are doing now? 4x plus 11 minus 11 less than or equal to minus 13 minus 11. So 11 cancel. So 4x is less than or equal to minus 24. Is it clear? Now I am having 4 multiplied with x on the left hand side. I want to remove that x. I want to remove that 4. So I multiply with multiplicative inverse of 4. So multiply with 1 by 4. Or in other words, we are dividing by 4. So 1 by 4 into 4x is less than or equal to minus 24 divided by 4. So here 4 cancel. So this is 6. So here we are having another solution set for the inequality, x less than or equal to minus 6. So for this, the solution set will be minus infinity to plus infinity. We are having minus 6 over here, and it is going to be closed. Why it is closed? Because we are having less than or equal to symbol. So this 4. If you consider this as a separate inequality, the solution set will be minus infinity to 3. For this inequality, 4x plus 11 less than or equal to 13, the solution set will be minus infinity to minus 6, closed. Now it is a system of linear inequality. So we have to have a common solution set. That is, the x value should be satisfying both the inequalities. It must satisfy both the inequalities. So what is the solution set which will satisfy both the thing? We try to draw a common line. Okay, real line. We are having 0. Okay, 3 will be on the right side. It is going to be the first solution set, less than 3. This is the solution set for the first inequality. For the next one, it is going to be minus 6. It is going to be closed and less than or equal to again. So we shade like this. Now what is the common region for both the solution? So common solution set will be minus infinity to minus 6, closed. Why we are not taking any number between minus 6 and plus 3? The numbers between minus 6 and plus 3 will satisfy only the first inequality. So we are not going to consider that as our solution. Okay. System of linear inequality will have a solution which will be satisfying the set of inequalities given. Okay. Now we will familiarize ourselves with another set of inequalities. Now consider this one. 5x plus 1 greater than or equal to minus 24. And 5x minus 1 strictly less than 24. So we consider the first inequality. 5x plus 1 greater than minus 24. Okay. What I should do now? What are we supposed to do? We must find the value for x. For that, we must try to eliminate first the constant and the next this constant to 5. So this 1 is in addition with 5x. So we have to remove that plus 1. So what we are supposed to do? We add with additive inverse of plus 1, that is minus 1. So 5x plus 1 minus 1 strictly greater than minus 24 minus 1. So 1 is cancelled. So 5x is strictly greater than minus 25. Again, I want to remove this 5. Phi is in multiplication. So what I should do? I should multiply with multiplicative inverse of 5, that is 1 by 5. So multiply by 1 by 5. So 1 by 5 into 5x strictly greater than 1 by 5 into minus 25. So 5 cancel. So x is strictly greater than minus 5. So the solution set for this particular inequality will be, solution set will be x is greater than minus 5. Okay, and minus 5 is not included. So any number which is greater than minus 5 will be considered for the solution. So the solution set will be open interval minus 5 to plus infinity. Open interval minus 5 to plus infinity. If you want to draw in the real number line, it will be minus infinity plus infinity, 0 somewhere, minus 5 left hand side. So greater than minus 5. So any number which is greater than minus 5. So minus 5 is not included. So we encircle, we take the right side value. So this is the solution set for the first inequality. Now we find the solution set for the second inequality. What is it? 5x minus 1 strictly less than 24. So I want to remove minus 1 first. So 5x minus 1 plus 1 less than 24 plus 1. So minus 1 plus 1 cancel. So it is 5x is less than 25. Now I want to remove this 5. So what I should do? Same process, multiply with multiplicative inverse of 5. 1 by 5 into 5x less than 1 by 5 into 25. Okay, 5 cancel. Here 5, 25. If you cancel, it is 5. Now x is less than 5. Now what is the solution set? For solution set for this expression will be any number which is less than 5. So upper limit is 5, lower limit will be any number less than 5. So it is minus infinity. So minus infinity to 5. Here also it is open because we have strict inequality. Is it clear? So if you draw the solution set, it is minus infinity to plus infinity. So we have 0, 5 on the right side, any number less than 5. We draw circle over 5 because the 5 is excluded. Now this is the solution set. Now we have to find the solution set for the system of linear equation. I already told you that solution for the system of linear equation will satisfy the set of inequalities. So here we are having a solution set, here having the solution set, we have to find the common solution set, the common value of x which will satisfy the first inequality as well as the second inequality. So we try to combine these two answers. Minus infinity to plus infinity. First one, minus 5 and to the right side. This is the solution set for the first inequality. Second inequality, we take plus 5. Okay. And we have to share the left hand side. Left side of plus 5. Okay. And very clearly, both n values, minus 5 and plus 5 are excluded. We are not including. Now tell me from the diagram, which is going to be your solution set, common solution set. We can very well see that the region between minus 5 and plus 5 is going to be the common region. So solution set will be x is less than 5. So the solution set will be any number less than 5. Okay, all the real numbers which are less than 5 will be the solution set for this particular inequality. So it is minus infinity to 5. If we draw the real number line and mark it in the real number line, it will be minus infinity to plus infinity. Okay, plus 5, we encircled with the 5 because we are going to omit that 5 and we have to shade the left side part. Okay, so this is the solution set for the second linear inequality. Now we are going to find the solution set for the system, that is the value of x which will satisfy both the inequalities. So we are going to combine these two answers. Okay. So we draw the real number line. Infinity, this is minus infinity. We draw plus 5. Okay, to the left of 5 we shade the region. This is the solution for the second inequality. Okay, now we mark minus 5 and we shade to the right of minus 5. That is your solution set for the first inequality. And both minus 5 and plus 5 are excluded. Okay, now from this diagram tell me which is the common region. Common region will be the solution set for the inequalities. Okay, so from the diagram we can very well see that the solution set is open minus 5 to open plus 5. Is it clear? Now we are going to see the next thing. Okay, so here we are having another system of linear inequalities. Okay, we are having the first inequality, 2 minus x by 4 less than or equal to 1 plus x by 3. Okay, this is a first inequality. We take the first inequality, 2 minus x by 4 less than or equal to 1 plus x by 3. Okay, and we are having left hand side not in the standard form, we try to simplify. Okay, right hand side we are having 1 plus x with the common denominator 3, but on the left hand side we are having the denominator only for x term. So we try to simplify that by taking LCM. So it will be 4. So 4 is multiplied with the 2, 8. 1 multiplied with x, it will be 8 minus x less than or equal to 1 plus x by 3. Okay. Now we are having 4 in the denominator for the left hand side and 3 in the denominator of the right hand side. So we try to remove the denominator on both the sides. So we take LCM for 4 and 3. 4 and 3 LCM will be 12. So multiply by 12 on both sides. So we multiplied with the 12. So 12 into 8 minus x divided by 4 less than or equal to 12 into 1 plus x by 3. So we cancel this will be 3, and if we cancel here it will be 4. So we try to simplify this expression. So this is 3 into 8 minus x less than or equal to 4 into 1 plus x. So we multiply 3 inside, so it will be 24 minus 3x less than or equal to 4 plus 4x. So left hand side we are having 24, so we try to remove 24. So we have to add by the additive inverse of 24 on both the sides. So it will be 24 minus 3x minus 24 less than or equal to 4 plus 4x minus 24. So 24 getting cancelled, so we get minus 3x less than or equal to 4x plus 24 minus 24, we get the expression as minus 20. So we try to simplify this further. Right hand side I am having 4x. We try to remove that 4x on the right hand side by adding with the additive inverse minus 4x. So minus 3x minus 4x less than or equal to 4x minus 20 minus 4x. So 4x cancel. Here we get minus 7x less than or equal to minus 20. So left hand side and right hand side we are having negative symbol, and we are having coefficient for x which is 7. So we must try to remove 7. So multiply by the multiplicative inverse of 7. So it is 1 by 7. So 1 by 7 into minus 7 by x less than or equal to 1 by 7 into minus 20. So 7 cancel. So minus x will be less than or equal to minus 20 by 7. Okay. 20 by 7 we divide. Okay. And before that we try to simplify this minus x. Okay. So we want to remove that negative symbol. So we multiplied with minus 1. So we get multiply by minus 1. So minus of minus x will be greater than or equal to minus of minus 20 by 7. So x will be greater than or equal to 20 by 7. So this is the first inequality solution set. Okay, 20 by 7 will be 20 we divide by 7. So 2 sevens are 14, balance 6, we put decimal point 60, 8 sevens are 56, balance 4, 40, so 5 sevens are 35. So it goes on. So x should be greater than or equal to 2.85. Okay. Now consider the second inequality. The second inequality is 3 minus x less than 4 into x minus 3. So we simplify. 3 minus x less than, we multiply 4 inside. So it is 4x minus 12. We try to remove that 3 on the left hand side. So we add additive inverse of 3 on both the sides. So it will be 3 minus x minus 3 strictly less than 4x minus 12 minus 3. So 3 cancel. So minus x is less than 4x minus 15. Okay. Now we have x term on the right hand side. We want to remove that one. So additive inverse of plus 4x is minus 4x. Minus x minus 4x less than 4x minus 15 minus 4x. So 4x cancel. So minus 5x less than minus 15. So I want to remove that 5. So it is multiply by 1 by 5. So 1 by 5 into minus 5x less than 1 by 5 into minus 15. So 5 cancel, we get minus x. 5 if you cancel, it is minus 3. Minus x is less than minus 3. Now what we are going to do? We have to remove that negative sign. So this is multiply by minus 1 again. So minus of minus x strictly greater than minus of minus 3. So x is greater than plus 3. Here x is greater than or equal to 2.5. Here x is strictly greater than 3. So what will be the common solution set? If you draw the diagram, minus infinity plus infinity, we take the first one 2.85. Okay, and the solution set for this one will be 2.85 will be included. Okay, the right side. This is the first inequality solution set. And x greater than 3. So we plot a 3 somewhere here. Okay, and it is going to be again right side of 3. It is going to be this one. Now what is going to be the common region for both the inequalities? It is x greater than 3. So solution set will be 3 comma infinity. 3 comma infinity. Is it clear? Now similar to this, we are going to do another problem. Okay. Now here also we are having the set of inequalities. The first inequality is 5x minus 7 less than 3 into x plus 3. Here the second inequality is 1 minus 3x by 2 greater than or equal to x minus 4. So we have to solve these linear inequalities individually. First we take the first inequality. So first inequality is 5x minus 7 strictly less than 3 into x plus 3. So we solve this. 5x minus 7, I told you already, we must have one term containing the variable and one constant term. We simplify this one. This is 3x plus 9. Okay. Now left hand side we are having a variable term which contains x, that is 5x, and one constant term minus 7. So first we try to eliminate this minus 7. So we add with additive inverse of minus 7. So what we get? 5x minus 7 plus 7 less than 3x plus 9 plus 7, by which minus 7 plus 7 on the left hand side are getting cancelled. So we get 5x is less than 3x plus 16. Okay. Now we have the variable term 3x on the right hand side. I want to eliminate that term on the right hand side. So additive inverse of 3x is minus 3x. So minus 3x is added on both the sides. 5x minus 3x, 3x plus 16 minus 3x. So 3x cancel. So 5x minus 3x is going to be 2x, which is strictly less than 16. So now I want to remove this 2 on the left hand side. Okay. So multiply by the multiplicative inverse of 2, that is nothing but 1 by 2. So 1 by 2 we multiply both sides. So 1 by 2 into 2x less than 1 by 2 into 16. 2 cancelled here. So we get x less than, if you cancel 2 here, it will be 8. So x is less than 8. So if you draw the solution set for this one will be any number, any real number which is less than 8. Any real number which is less than 8 is nothing but minus infinity to 8. If you draw a real number, it is minus infinity to plus infinity. We are having 8 somewhere here, and any number which is less than 8. So this is the solution set. 8 is included or excluded? In this case, because going to be this strict inequality, we eliminate. So we exclude 8. So we draw circle at the point 8. Now take the next inequality. The next inequality is 1 minus 3x by 2 greater than or equal to x minus 4. Okay. Now we are having 2 in the denominator of 3x. Okay. It is going to be for only one term. Okay. So first we try to eliminate this one in that case. Okay. Right hand side we don't have any denominator, so it is very comfortable for us. So we try to eliminate that 1 which is on the left hand side. So we take additive inverse of 1, that is nothing but minus 1. So 1 minus 3x by 2 minus 1 greater than or equal to x minus 4 minus 1. So left hand side plus 1 minus 1 cancel, we get minus 3x by, which is greater than or equal to x minus 5. Okay. Now I want to remove this 2 which is on the denominator of the left hand side. So I multiply by 2 on both sides. Why we have to multiply by 2 on both sides? Because the multiplicative inverse of 1 by 2 is 2. So it is 2 into minus 3x by 2 is greater than or equal to 2 into x minus 5. So 2 to cancel. So what we have now? Minus 3x is greater than or equal to, because 2 is cancelled, so we have only minus 3x on the left hand side. Greater than or equal to, we multiply 2. 2x minus 2 into 5 is going to be 10. So I want to remove that 2x which is on the right hand side. So what I am going to do? Minus 3x minus 2x greater than or equal to 2x minus 10 minus 2x. So 2x and this 2x is cancelled. So we have minus 5x greater than or equal to minus 10. So I am having 5 on the left hand side. So I want to remove that 5. So what I am supposed to do? Multiply with 1 by 5. So we multiply. So 1 by 5 into minus 5x greater than or equal to 1 by 5 into minus 10. So what we get now? 5 and 5 cancel. So it is minus x greater than or equal to, if you cancel 5 and 10, it is minus 2. Minus x is greater than or equal to minus 2. Now you want to remove minus. So multiply by minus. So when you multiply by negative sign or minus 1, the inequality get reversed. So we get x less than or equal to plus 2. Okay. Now I am going to draw the solution set for this. Solution set for this will be any number which is less than or equal to 2. So it is minus infinity to 2. Closed. So I want to draw the solution set in the real number. So 8 is here. So 2 will appear only here to the left hand side of 2. And we shade this 2 because 2 is included. And it is going to be left side again. So it is going to be this one. Okay. Now which is the region which is going to have both lines? Okay. Clearly the solution set for the system will be minus infinity to 2 closed. This is the answer. Is it clear? These are going to be very simple system of linear inequalities. So here we have inequality 4x plus 1 greater than or equal to 0. Okay. So what will happen? Right side we don't have any variable or constant. We have only 0. So no issues for us. So first we try to remove plus 1. So what I am supposed to do? I add with additive inverse of plus 1, which is nothing but minus 1. Greater than or equal to 0 minus 1. So 1 is cancelled. So 4x is greater than or equal to minus 1. Now I want to remove 4. Okay. So multiplicative inverse of 4 is 1 by 4. So multiply with 1 by 4. So 1 by 4 into 4x is greater than or equal to 1 by 4 into minus 1. So 4 cancel. So x is greater than or equal to minus 1 by 4. Okay. The solution set for this particular problem, solution set is going to be any number, any real number which is greater than or equal to minus 1 by 4. Okay. Which is nothing but minus 1 by 4 to infinity. The right side part of the interval. Okay, after minus 1 by 4. Now take the second one. Second one is 3 minus 4x is less than 0. 3 minus 4x is less than 0. So we have 3 on the left hand side. We want to remove that 3 because it is only appearing in addition or subtraction. Okay. So it is 3 minus 4x. So additive inverse of plus 3 is minus 3. Less than 0 minus 3. So minus 3 cancel. So minus 4x is less than minus 3. Now I am having the number 4 as well as negative sign with x on the left hand side. So first I try to eliminate 4. So multiplicative inverse of 4 is 1 by 4. So we multiply with 1 by 4. So multiply with 1 by 4. So 1 by 4 into minus 4x less than 1 by 4 into minus 3. So 4 cancel. So we have minus x less than minus 3 by 4. Okay. Now I am having negative sign with x. So I multiply with minus 1. So when I multiply with minus 1, so minus of minus x greater than or equal to minus of minus 3 by 4. So x is greater than or equal to plus 3 by 4. Okay. So here we are having equal to symbol and it is going to be greater than or equal to 3 by 4. So the solution set for this inequality will be 3 by 4 to infinity. So we combine both the thing and to find the solution set we take the real number system. First we try to draw this solution set in the real number system, minus 1 by 4 to infinity. We take minus 1 by 4 till infinity. This is the first solution set. The next one is 3 by 4 to infinity. Minus 1 by 4 is negative part which lies to the left hand side of 0. 3 by 4 going to right on the right side. 3 by 4. 3 by 4 to infinity, it is going to be this side. Now what is the common region? Common region will be the solution set for the given system of linear inequalities. Okay. Now which is the shaded portion which has both the solution, which is nothing but 3 by 4 to infinity. So solution set will be 3 by 4 to infinity. Now let us consider the another set of linear inequalities. Here we are having the first linear inequality, 4x plus 3 greater than or equal to 2x plus 17. And the second inequality is 3x minus 5 less than minus 2. Okay. Consider the first inequality, 4x plus 3 greater than or equal to 2x plus 17. We must try to eliminate 3 on the left hand side. So we add with additive inverse of 3, that is minus 3. So 4x plus 3 minus 3 greater than or equal to 2x plus 17 minus 3. So left hand side 3 cancel. So we get 4x is greater than or equal to 2x plus 14. 17 minus 3 is 14. Now 2x is on the other side, right hand side of the inequality. We want to remove that 2x on the right hand side. So we have to add by additive inverse of 2x. So 4x minus 2x greater than or equal to 2x plus 14 minus 2x. So 2x cancel. So 2x is greater than or equal to 14. So now we have 2 with the multiplication with x. I want to remove that 2, eliminate 2, so multiply with 1 by 2. So 1 by 2 into 2x greater than or equal to 1 by 2 into 14. So 2 cancel, so x is greater than or equal to 7. So x is greater than or equal to 7. The solution set for this will be, this particular inequality will be 7 to infinity, any real number which is greater than 7. Okay. Now consider the other inequality, 3x minus 5 less than minus 2. I want to remove this minus 5 first. Okay. So 3x minus 5 plus 5 less than minus 2 plus 5. So minus 5 plus 5 cancel. So 3x is less than plus 3. Now I want to remove 3. So what I am supposed to do? I have to multiply by multiplicative inverse of 3, that is 1 by 3. So we multiply 1 by 3 into 3x less than 1 by 3 into 3. So 3 cancel, here also 3 cancel. So we get x is less than 1. Okay. So here we are having the solution set, x is less than 1. That is minus infinity to 1 open. We try to find the solution set, common solution set. Okay. So we try to draw the diagram. One is minus into plus infinity marked with the 7. Okay. 7 to infinity means to the right side of 7. This is the first thing. The next one is 1 minus infinity to 1. So it is going to be this region, minus infinity to 1. And we are excluding 1. Do you find any common region here? We don't have any common region. Okay. So the solution set for this set of inequality will be null set. We don't have any common region. Okay. So in this session we have studied about application of linear inequality in real life. Okay, where we are applying this concept of linear inequality, and we found out the solution for system of linear inequality. Okay, thank you students.